Hey, welcome back to part 10 or 11 of our series. I think it might be part 11 of our series, our now legendary series, I'm sure, of creating a 8-bit virtual console using AI and using AI to then code things for the console. Um, Going to hopefully do a shorter video this episode, um, to generate essentially images or help us convert PNG files, JPEG files, etc., into images we can display in the console. And I'm doing this for a couple of reasons. One, I think it'd be really cool to see like old school 8-bit loading screens in our console, and the other is it might help us get sprites and things into the system as we push into that side of things in the next few weeks. So I've created this spec. And it looks a bit like all other specs. I'll call it image generator, and this is what I want the system to do basically. Our normal preamble, I've also given it this file to read. That's where we're going to essentially kind of make the change. That's our editor. We're going to add a button. So I wanted to add a button basically to a toolbar. So in our system, we've got our assembly button. I'd like a image, sort of generate image button in there. Add an image, create a dialog when it's create a button rather. When the button is pressed, create a dialog, giving it a title for that. We're going to then let people upload files into that dialog. I've asked it to use FilePond, a really popular component for doing that kind of thing. I've used it a lot. It's great, just works. So we'll use FilePond. Then when the user's uploaded an image, you press generate. We wanted to do a few things. Essentially, we wanted to target mode 0, which is the video mode we've been using so far, which is 256 by 160, 4 bits per pixel. And what we're going to do basically to generate assembly code that renders the image by loading all the bytes of the image into the program, and then having a little render of it outputs it. At least that's the plan. So before generating byte data for assembly, best fit size it so it fits within our resolution. I've noted here before generating the bytes for assembly, so don't try and generate all the bytes for a very large image, which won't fit in 64K of RAM, minus the rest of the RAM. One approach we could take with this, I've not taken this here, but one approach we could take, just because I'm thinking ahead to things like sort of cartridges and things, but we could actually have just rendered the bytes directly into a frame buffer and had our program start at, our .org start at B, I think it's B000, the start of our frame buffer. We could literally have just rendered bytes directly into a frame buffer, and that would work. But I'm thinking ahead to carts and things, so let's create a little program. Anyway, we also want to convert it to a 16 color palette, so we'll get it to sort of choose the best palette it can for our image. There's various sort of palette optimization algorithms. I'm just going to let the LM do as it sees fit with that. We want it to contain output assembly that contains a label called bitmap with all the bytes of the resize and palette optimized image. We want to clear the screen to black before we draw it, and then draw the clear the screen to black. I'm going to actually make this a bit more explicit. Some people should I clear the screen to black. Draw the retentive screen, and we want the program to replace the current program editor. And I wanted to create a reusable dialog component because we're going to put more dialogues into here. And I've also pointed the LLM at our assembly examples because I'm pretty sure there's useful code in there for doing this. In fact, if you've been following along, I did a slightly different bitmap generator with lots of clear screen examples. So we'll point it at our existing examples. And we'll see what happens. So if we go to our console, I've got Claude running in our dev-kit client folder. Let's paste in the request and let it trundle away. I'm almost certainly going to snip a little bit of content out of the video here because it's probably going to take it a few minutes. And I don't think you need to hear me prattle on for that long about whatever is randomly in my mind at the moment. So I shall leave it there, and no doubt this will look like 0 seconds to anybody watching. To me, it might be a few minutes. Okay, apparently it's complete. Let's see. I'm just going to give it a go first. First things first, I'm just going to give it a go. Okay, great. We've got an image button. That's a good start. And we've got a dialogue. Another good start. Okay, I have an image I kind of grabbed earlier. This is from a BBC micro game, Exile, which was released really late on in the BBC's life. It's amazing, an amazing technical feat. Sort of little life simulations and a physics model, procedural generation. I mean, it's basically a physics puzzle back in, I guess, about 88. Crazy. Yeah. Let's press the generate button. Okay, so it's generated some code. We expect quite a lot of bytes down here. Okay, that looks at least vaguely sensible. Setting up the palette. Okay, so it's chosen some colours from the palette. It's cleaning the screen. That looks like a clear screen for one of the samples, I think, which is absolutely fine. Draw bitmap. Okay, let's just see what happens. Assemble it, run it. Okay, so not quite. It's not complete garbage. The colours look about right. Okay, well, that's probably easy bit though. So let's. What we'll do actually is we'll save image as. Nope. Yeah. I tend to this way all my little dodgy, my broken files and sample files is my garbage ground basically. I'd like to say my dodgy files, which sounds really dodgy, but just my my garbage ground. Okay, let's go to Claude. Okay. That's what I saw, and we'll grab the image we just saved. This is what I expected. And the colours look about right, which is, but I guess that's the easy bit. Okay, let's see what happens if I give it that. Again, I might snip a bit here. I'll see how long it thinks for. I'll give it 2 images, so it's probably going to think for a little while. My suspicion would be, while it whirs away, is that it's in this draw bitmap code. If you recall from the Pong game we created, I had to help it with drawing the bitmap previously, and that was an 8x8 bitmask type thing that we were, we were basically wanting to render on the screen in a single colour. This is a bit of a spin on that, in that it should in theory probably be copying entire bytes over. I guess there might be a nibble alignment issue if the image that is generated has gone odd width or height. No, width wouldn't odd height wouldn't affect the byte arrangement, but odd widths might when you start on like a nibble rather than a byte, if that makes sense. Yeah, my suspicion would be it's in here, but let's see what it makes of it. Okay. Okay, so that's not massively dissimilar to what I was talking about. I mean, it's about a byte packing. Okay. So it is kind of what I was talking about. Yeah, interesting. Let's see what happens. I want to refresh it, aren't I? Okay, let's pick our image. Oh, so many fond memories. Okay, I've got an assembly error this time. I guess it's going to be a branch range issue. Okay, so I'll ask Claude to resolve that. We go to Claude in our next row label as part of the bitmap render, getting a branch range error. So just a reminder, branches can only go plus or minus 127 bytes. So you often have to sort of two-stage them. If you want to jump further, you have to essentially branch to a closer label, as I guess it's doing here, and jump further. What it looks like what's actually in here is just reverse the check, and it's just reversed the check and moved on. But let's see what that does. Okay, let's refresh this. Fingers crossed. Okay, let's generate the image. Okay, no errors. Let's go to the console view, assemble it, run it. Still not quite right. Okay. Let's just again. Oh no, I did this, didn't I? That's why I did it that way. Okay, so Exile broken 2. Okay, still not right. I'm persisting with the AI because if the AI can't resolve it through me poking and prodding it, I'm going to have to do some quite sort of painful work, which is I'm going to have to look at the actual generated bytes, make sure they're correct. And probably the way I would do that is convert them back to a PNG, if that makes sense. I'd probably convert them back. Render them out just to verify that the bytes are correct. It'd be easier than cross-checking against the image. Just take those bytes and generate a PNG from them. Wouldn't even be too bothered about the colours. We'd just see if it looks the right shape, and then if that's correct, or we'd get that correct. If that's correct, we would our next step would be to handwrite the assembly to render it. I can see, let's have a quick look. Okay, it thinks it's resolved it. Okay, assembly error. It's fine. It is going to be in how it's doing with the memory. You can see from the way it's sort of kind of offset. But I can imagine having to sort of do some handwriting here, which would be a little bit painful to have to do that again so quickly. But I can see why. Okay, so no errors, that's good, that's a good starting point. Let's compile it, let's run it. Still not right. Okay, we're heading closer to doom. Heading closer to doom. Okay, let's do another go. Fortunately, these images are quite small, only sort of 26K each, so I'm not completely burning through my Claude credits. If I end up out of Claude credits, I'll have no choice but to do it manually. Tinkering with palettes, it's definitely not palettes. Okay, I think it's okay. So see if this works. I can see what it's saying. Essentially, we've packed the colours into 4-bit per pixel mode. So the bytes of a bitmap are storing 2 pixels each, which is what we want. But it's saying it's passing those into draw pixel, and I suspect draw pixel is. I'll double check. It's probably one that's pulled from our samples, which takes, which draws a single pixel, and is it not expecting, to draw both parts from a nibble. Let's see. Let's refresh this. Of course, the worry now is that the image is too big for memory. Yeah, it looks like our standard draw pixel from our from our code. So that's that image. It does start with zeros. Okay. Okay, I'll just eyeball the image, see what that would do. Let's assemble it. It assembles okay. Or we never have any errors over here. It's still not right. Okay. Okay, we're getting near to the point of doom. So look at the generation code. We've not looked at the code. That's a palette, fine. Let's put that in there because our palette is previously just in the shader. If you recall, we've not got any kind of reference to it in the code. Okay, so it's using color distances to pick the palettes. That's fine. Find best palette. Okay, I'm not interested in the palette right now. Okay, first image. Okay, convert image to okay. Let's see. So this is just putting out the pixel data. I'm going to see if we can see. Okay, so it's fine because it's palette. Okay, fine. And it's pushing the palette index. Yeah, so in pixel data we end up with 1 byte. Yeah, so even though we're using half a byte, we've got 1 byte per pixel. I'm going to ask it to create a diagnostic image here after it's created the pixel data, but we can at least see if it's got the structure of that right, that it's read that right. That way we know that I bet it's a good idea. Oh, no, it's just going to do it. I thought I might get one of those chatty, great ideas. Clearly not a great idea. I mean, looking at what it's done, it looks okay. In terms of the This might fly around a bit, but it kind of looks okay. X, Y, go through, Y, X. So we want it to go horizontally, pack the colours. It looks okay. I'm pretty sure it's in our renderer, but in the render assembly, which is the worst place for it to be, because that means I'll have to write that by hand, which is a fun thing to contemplate. If I do have to write this by hand, what I'll probably do is go off screen, go downstairs with my laptop in laptop mode, and put on maybe a cheesy action film, Conan the Barbarian perhaps, Total Recall, something Arnie related, get the old motivation going, and crank out some assembly, and then come back and resume a recording. But we'll sort of poke it around a couple more times and see where we get to. Make sure it's refreshed. Let's get our image. Okay, that looks good. That looks pretty good. It's done a pretty credible job of a resize and the but it just doesn't work. Okay, so let's okay, start X, start Y. Let's look at the variables. Draw bitmap. Center X, center Y. So look at the draw bitmap code. Load power index from bitmap. Is that not the wrong way around? Isn't it high-low in the register and low-high in the 0 page? Let's consult our spec. Let's go to the CPU spec. So for address mode on 2.5 down the bottom. Near the top, isn't it? Addressing modes. So we're looking for a register. So 0 page indirect is okay. 0 page, no. Okay, so 0 page indirect. So yeah, low byte, high byte. But I think registers are high byte, low byte. Yeah, R2 high, low. So I wonder if that's the problem. It definitely wouldn't help. That's right, low byte, high byte. Ah, there we go. It just confused the register order, the indexing mode. I wonder if we should align those two. I've kind of pulled from the two sources, the 6502 and the Z80, for the two modes, the 0 page index mode and the register pair mode, but the high, low, low, high, yeah, I might have to relook at that. And align them. I think I've probably pulled 2 different styles from the 2 different CPUs and ended up with a strange mashup. But yeah, fantastic. Woo! I managed to debug the assembly. That's great. Let's just fix it in. We need to fix it in the source, so the .col loop, isn't it? Just check I got that right. Yeah. Okay, so it's there. The .col loop. So let's go to our image generator. Just make sure it's a bitmap yet. Okay. Great. Let's just then refresh and make sure that works from scratch now. Okay. Load the image. You don't need to see my download folder. Load the image. What you'll see is thumbnails for the videos. Okay. Generate process the image. Okay, that's what it's going to look like. Generate the assembly. Now console, assemble, run. Works this time. Great. Let's do a commit. How are we doing for time? It's supposed to be a short episode. 30 minutes. Okay, we're doing okay. Every time I go a bit ambitious, it goes wrong. But let us see. Let's go to. We just need to find. Let's commit. We just want to commit. Now I think it'd be better if we could move back to the nibble approach, basically, because that's going to be less. I think it'd be less work to do. Just take the nibbles, copy the nibbles, rather than moving one at a time. We could move 2 at a time. You know, a byte at a time rather than essentially like a half byte at a time through the source. And we want to pack it as nibbles that will move less space. At the moment, our actual byte pack is using more space than our frame buffer, which is bad. It's not great. And so we're working, I think, because we've got nothing else in memory. So let's see if we can do something about that. Okay, so fix the issue. Problem was you were using low byte high byte for register indexed addressing, register pair addressing, whereas it's high byte, low byte. 0 page is low byte, high byte. Okay, but that's fixed. Oh, I didn't mean to press enter. Never mind. Let's see, to make sure it doesn't change any code. I don't want to change any code. Excellent catch. Thank you. I feel good about myself now. Oh dear. Not a good idea to take your validation from an AI. I think that's. Externalizing your validation is never a good idea. I think externalizing it to an AI is probably a really bad idea. Cool. It looks great. Let's just check it hasn't changed any code, any further code. That would be bad. It hasn't. Okay. Image generator. There it is. Look. Image generator. It hasn't. Okay. Okay, can we update the code to pack the bytes into, to pack the image, how to think this, to pack the bitmap using the 4-bit pixel nibble approach and update draw pixel so it understands that it's being passed a byte that represents 2 pixels. Align the packing on a packing appropriately. It has to start at an even X pixel position, 0, 2, 4, etc. So we only need to pack it right so that we can just say, byte from 0, byte for 2, byte for 4. If a pair of colours started at x1, that wouldn't draw properly when we pass it to draw pixel. Okay, that's just before we ask it to do that, because I think it's interesting. Like, if we get performance improvement from doing that, I think we will. Let's reset the console, assemble. You can see that draw. Let's see what happens if we, if we take this approach I just talked about. I love seeing it draw. It sounds silly, but it takes me right back to the 8-bit days, which I love. Fantastic. In any case, let's see if with all that work, we can get Claude to do this last step for us, because again, I don't particularly want to have to do it myself, and I think all that was wrong was that low high byte mix up. Okay, so that's for nibble packing. Okay, that's it, unpacking it for the preview. That's the easy bit. I think actually with us having corrected the register pair index, I think it will work absolutely fine. I'm wondering if one thing I might do is sacrifice some colours in our palette. The palette is based on Tailwind, a sort of hardware palette. The full hardware palette I've given it is based on Tailwind. I might sacrifice some colours in the palette to give it a set of more 8-bit primary colours, like the bold, strong colours that you would have had on an 8-bit computer. I will, of course, probably use a BBC as a basis for that. But that might be, I think, helpful given the sort of era of the console. Tailwind doesn't have those primary colours in its palette because they're not on the sort of kit we have today. It's a bit of an eyesore looking at like red with an RGB of 100. It'd be a bit painful. Okay, let's see what's happened. Let's reset that. Let's load our image. Yeah, you can see it's more sort of primary on the BBC, like stronger colours. Okay, well that's fine. I mean, it's packed and unpacked. Let's see what happens to generate the assembly. No errors. Okay, shorter, smaller look, which is what we kind of would hope for. Let's assemble it and run it. Great, and it was quicker to draw, which is kind of what we expected. So, great. With a bit of sort of manual intervention to debug something, we've got to a good place. I think lesson learned, particularly if we're going to use the AI assistant, is I think I do need to align the byte order of the register indexing and the zero-page addressing, register addressing rather. As we're going to keep tripping up over that, I think it does mean I will probably have to refactor existing programs. Oh, but it shouldn't be too hard, right? I just need to find all the square bracket R0 cull and I can do it with regex, I should think. I could probably get the LLM to do it. We'll see. That might be a little bit interesting. They wouldn't need to understand. I probably wouldn't have to ask it to understand the assembly. I'd just tell it to replace things of that pattern with the reverse and give it some examples, and that's the sort of thing I think it would do quite nicely. But yeah, great. So a slightly shorter episode than usual. Not an hour's mammoth, but again, I think really kind of interesting results, and we can hopefully, I should have done this earlier, sort of, blow it up a bit, and great. The BBC Classic, amazing. Yeah, great. Awesome, great. Let's end it there, and see you in the next episode.